This is IBM Museum. Recently I gave the revelation that the IBM PS2 Model 55SX does not have the extended CMOS RAM. Now I knew that some of the early models of PS2, notably the Model 50 and 50Z, being based on the 286 CPU, didn't have a extended CMOS area. They don't have any form of chip or anything else that is battery backed up that they have that space to use. And with 4 adapters maximum on the Model 50 and 50Z, that's not an issue for them. They're able to store that configuration of those adapters in regular CMOS. The 55SX, as discovered, we went over that on video, bringing up the UNPC program, also has a maximum of 4 microchannel slots, what are recognized as adapter connections for microchannel. And so it would be fine with regular CMOS as well, but it introduced something else that just nagged me in my brain, and I knew I'd done this years ago, to where, being that it's a 386 based computer, and Intel, when they first came out with the 386 CPU, it had no DX or SX designation at that point, although it was what turned into the 386DX. And that 80386, they gave what was called a CPU reset signature on. When the CPU started up, it had a value in the DX register that the computer, could save away, that told what CPU and stepping value it was on the computer. And that wasn't really used all that much at the time. The 286 and earlier CPUs that Intel developed did not have that functionality, just something new on the scene. And Intel went through later on, and once they split up the 386DX and the 386SX, and the 386SX is it's normally in a plastic packaging rather than the 386DX being in that ceramic packaging, and the 386SX is soldered, to the motherboard or planar. It makes it hard to go through and to upgrade that CPU. There were some clip-over upgrades that had this really convoluted way of just latching on top of the CPU and going through and trying to disable it, and running, its place, kind of just an alien on top of the face or something like that. And the earlier 386SX CPUs, they had there was a pin called, and it's typically with a leading negative sign, and it's called the float pin. And that makes the 386SX float its pin values. It effectively goes through and puts the CPU in an inactive state. And on the early versions of the chip, that float pin was not functional. In particular, on the A-step version of the 386SX. It's going to be one of those nights again. I have a hard time pronouncing or saying 386SX. But so it was, that CPU reset signature was kind of critical in that instance for determining if that CPU had the ability to be disabled, and an upgrade would work. And even a particular interesting aspect of this 55SX that I have behind me is that it has a cyrix CPU on there. I'd have to look up what I've got the manual for it. I've covered that in previous videos, but it's a substitution for the 386SX. Solders right in place, and that looks to be have done by IBM themselves. It's a very professional job. It's not marked on the badge or anything else. It's just some system I picked up, and for everything else I could tell, the owners the previous owners of that weren't really aware it's not badged that way on the unit really at all for that main badge. And it's just enhancement. I mean, it gives improvement of what the CPU was able to do. So, of course, it became kind of the lead 55SX that I had. I have gone through and I've run, I know that I've run the routine to get the CPU reset signature value. I've even gone through and I've developed a page. Let's go through and just put that up on the screen. There'll be some pauses as I'll go through on this and how I rearrange things around. But this is a function call. Let's get where we can work with this, interact with it as well in OBS. It's just an interrupt call that goes through and retrieves that reset signature from where it's stored on the system and reports it. It gives that return value, and through kind of a sorting process of what the return value is, I'll link this page in the video description. You can figure out what the chip is, what the CPU is, without even visually looking. And this is a way to tell it, what it is in software. And primarily, I'm addressing the Intel-based CPUs here with the chart. There are also, the cyrix substitutions that IBM even combined with later on or worked with to do some later CPUs. IBM did, they had a arrangement with Intel that they could go through and use those code masks from the CPUs and develop their own, basically, that they would have on their own machines. They could not go through and put them, sell them to other vendors to compete with Intel. But they developed some really neat chips like the 46 SLC 2, or even before that, the 386 SLC. CPUs, even for that 386 marking, that could run 46SX instructions on the chip, had a big of cache, L1 cache as the 46 class chips did from Intel. The 46 SLC2 and SLC3 that IBM did later on had even a 16 kilobyte cache. And I mean, could just go through. They were still 16-bit processors, 24-bit address lines, so limited to 16 megabyte of memory on the system maximum, but very fast CPUs, very capable CPUs that could replace the Intel 386SX on systems. And there are other methods of, like the cyrix chips, to go through and determine the same things. Later on, Intel turned that into the CPU ID instruction to get that value on the fly from the CPU, just at any point in operation. And it began to be identified a little bit more in the things like the Windows 95 and other user interfaces to show, what level the CPU was at. Early on, it wasn't really all that critical, but it's good values to know. And so I went through and, since I had this routine up and I knew from what it said, let me get to the point where, okay, so I've got the notes, and I've got, the BIOS must save DX at startup in order to support this call. PS2 BIOSes merely report the extended CMOS location at offset 190 hex and 191 hex. And, I'm not worried about the 286 CPUs. I know that they don't have a CPU reset. But I thought, hey, the 55SX doesn't have extended CMOS. Where does it get those values from? It doesn't have extended CMOS to save those values away. And this is before the CPU ID instruction came out, so that the system had to go through and save those values to report them later. And I was sure that the 55SX had gone through and had done that for me. So I'll have to go through and change a little bit to this page. I went through, and as you can see at the bottom, there is the supported models, and there is also, the 55SX is listed for one of them. Just basically every IBM PS2 that had a 386-SX or above had this functionality to support this call. But I also got looking at, there's ISA models. Everything that's below mol 50, for PS2s, is not microchannel. It's ISA for a lot of the models, like the mol 25SX is listed here. The model L40SX is listed there. These are ISA systems, and they don't have an extended CMOS. So it just further opened that door to say, wait a minute, I listed this information. I talked about that value being of the CPU reset signature being in that extended CMOS location. Where do these systems get that? And so I threw the question at Major Tom. I knew that he was great at finding out, being the super sleuth that he is, and going through and locating those, just doing a little bit of digging. And so he gave me a response, and let me go through from the mol 55SX, get that up to where I'm on the screen here. And as you can see, I'm loading the driver for the that Cyrix had for this CPU, and I guess it's identified here as the CX46 DRX2, and that just means it's clock doubled internally. It's in the 386SX format, but it loads the drivers and enables the cache, and basically turns on the functionality of that CPU. Now that can have some side effects, as I kind of learned, and I'm going to turn around. I'll face the computer, because we're going to get into the UNPC program. Okay, and actually let me get in. I'm not sure if I've got that in my path, so let's change directory to the UNPC directory first here. And then let's run the program. So it has this system information setting, and at the very top it's got the CPU information area. And I've done a little bit of preview of this, work on what the video would show. So I know that this will go through, I select it, and I've gone through and please waited for several minutes. Sometimes the tables and everything else loading here, it takes a little bit of time, but the system is ultimately locked up. There's just a side effect of the Cyrix CPU in there. It's just something's not right in that decoding that is throwing the machine off. And it may be looking even at that area, trying to find the CPU reset signature or something else there. So since the boot up process of this is rather slow on this 55SX, for all that memory count and everything else, I'm going to pause the video, and I'll be right back after I restart the system from this lockup. Okay, and I'm back after that long boot up cycle after that lockup. And so I mean, we didn't get any information at all from the UNPC book. It just, you know, that portion seized up. Now, I knew I did have the cyrix utilities on the system as well. And just basically there's, you know, an installation routine. It goes through, and for some of the stuff like the operating system like OS2 or Windows even, there's a way to go through. And then even for if you have a math coprocessor that's on your system. And I think I do have a math coprocessor actually. I think it's just an Intel that's on there. But the one thing I know that there is and I think that there's even some ways you can go through and you can like slow down the CPU or work with the cache to make it more compatible or not have those instances that it locks up. But I know that the one program that they had here was this RXTestcom program. And I thought, well, let's see what that gives us. And, you know, exciting 46 system upgrades from Cyrix are coming soon. I think they've already come or whatever. But so it does give some indications there of and it talks about not a fully terminated bus. And I'm not sure what exactly they mean by that. But that maybe is what is causing the issues here. But it says your CPU's ID is 0411 from the type 0A hex reset. And that's ultimately from the functionality that Cyrix created. In other words, the methods they created on the CPU for model-specific registers to do some stuff and to ID the chip and turn on cache and things like that. But there's a way to ID the chip, and that's what they're referring to for that 0A hex reset. Now, below that, they say your CPU's ID is 0411 from the BIOS. Okay, and that's what I'm focused on here, is saying, wait a minute, if it's from the BIOS, and I know that that's referring to this, get to where we can interact with this again, get up to the top of the page. That's referring to this interrupt call in BIOS, the int 15 hex function C9 hex. Get CPU type and mask revision. So it's going through and kind of teasing me that it's getting it from that BIOS call. I know that works on the 55SX. And by the same thing, and I tried, all kinds of steps here as well, even the Control-Delete key sequence, but the system is locked up again. So I'm going to pause the video, and we're going to restart that long restart process, and I'll be right back. Okay, we're back at the command prompt. And so that's the point that I asked Major Tom to go through and to I know he examines the system BIOS, and there were some images that we had that captured that's what he did. He went through and he looked up where this interrupt function call referenced. And he told me, well, it's in the extended BIOS data area. And that's normally called the EBDA, and that's something that IBM added on, when they came up with their a little bit more advanced models of systems, that they went through and created an extended BIOS data area, and that's where the BIOS actually saves some values away, and it actually makes sense for all this. That CPU reset signature, you get it from every boot. It doesn't have to be saved away in an non-volatile RAM. Preserved, in the CMOS settings, if you can retrieve and get that value every time. And it makes more sense putting it into that extended BIOS data area. Now, to look at the extended BIOS data area, there is, in fact, I need to go through, because I need to adjust OBS and actually show the page that I have, and I need to populate this actually better. So let me pause the video. Okay, and there are ways to go through and to get the segment of the memory segment of where that extended BIOS data area is. And I actually need to populate this page a little bit more, because I've gone through and I put all the header and information in there, and I need to go through and actually put some data in there. But I know of other ways to get that EBDA segment address. And you don't even need the UNPC program or anything else. You're fine with DOS Debug. And you can do debug. I'm going to face the screen behind me just so I don't have that screen lag. And we can do a dump. And we go through a particular BIOS data area of just, and I don't know, probably I should type it out with zeros just to be a little bit more descriptive. It's all the same thing. The zeros, I didn't have to have in there. You have to have the colon in there, and at least 1 0 following. And it's a segment, and then that leads there. And then I'm going to just do a length of 10, just one line, 16 bytes. Okay, and this is normally where the BIOS saves away the addresses for the serial ports, parallel ports, for instance, we have that 03F8, the 2 columns, and of course it's Big Indian, or it's inverted from the most significant byte and least significant byte, but that's the address, the I/O address of the first serial port on the system. And then the following zeros, and you have 3 more blocks of zeros, just 0, 0, 0, 0, 0, 0, meaning that there's no effective COM2, COM3, or COM4. And then following that, you have 03BC. And that is the I/O address of the printer port, or the LPT port. And the 2 groups, the 0000 and 0000 following it, means there's not an LPT2 and there's not an LPT3 on the system. But it's just the way when the system starts up, it has these values of what the I/O addresses are for the parallel and serial ports that are built into the planar in this case, or could be on an adapter otherwise. But it hasn't interrogated the system when it started up to figure out these addresses, and there's not normally the consideration for an LPT4 on a system, or IBM used the last 2 bytes on this line, and again, it's inverted. It's Big Indian of 9FC0, and that is the extended BIOS data area segment. So we can do the, we put in the segment, well, we put in dump, and then the segment that we want to look at. So the 9FC0, and we want to do from the start of that segment, that at the 0 address, and in this case I'm going to go through and I'm going to say length 160, and that's in hexadecimal anyway. But I'm choosing to display more than a standard, just issuing a dump command and giving it the memory location. Okay, so there's the extended BIOS data area, at least the start of it. And Major Tom told me, yeah, I looked, and the place that stores it is in the in the EBDA segment at the B6 and B7 hex locations. And that's right squat in the middle of the screen. That's that 11 and then the 04. And it's, in this case, it's again, it's Big Indian, that the 04 is the class of the CPU. And normally on a 386SX, this would be the, this would be the CPU family. So the 386SX is listed at the very bottom of this page. I mean, it starts out, it's got the 386DX areas, but down towards the bottom I have, for that CH equals 23 hex, that's dealing with the 386SX. And those stepping values, 04, 05, 08, being the different stepping values. 04 being the A0 step, the one you have to watch out for. It doesn't have the functional float pin. And the B step, where it's included, and then the C step where a lot of this stuff was resolved. That that you have a CPU with the this worked out some of the bugs and has a working float pin for the 386SX family. So getting back to my extended BIOS data area, I mean, and we saw that earlier, the cyrix program teased us. It said the value return was 0411, and 04 meaning the 46, is the CPU family, 46 class CPU, and the 11 meaning particular decoding in the cyrix world, not really relevant to the Intel aspect. But I was glad that he had, identified what area that was in. That I knew where, in the case of a 55SX, where it was getting that value for the CPU ID and the stepping of the model. So I got thinking on other systems. I guess I stopped interacting with the page. Let me get down to the. I thought from there, hey, let's look through, and for the Model 25SX, we've got that L40SX as well. They're not microchannel systems. They don't have an extended CMOS RAM on those systems, being that they're not microchannel systems. So we're going to swap to and get a 25SX up on the bench. Okay, and this system is going to boot up a little bit quicker and we've looked at this before. This has the New Deal School Suite software on it. I don't want to go through. I mean, we ran through that, showing that software before. I just am going to do a control break so we can get and terminate that batch file that would have loaded the New Deal software. And I'm going to get facing the machine. With the screen lag, I actually give another line feed. So I do have the, I mean, this is another model that I knew I was testing to get the CPU reset signature on. And so we're going to get into the UNPC program again. I just wanted to see that it has going to the same place with that CPU information, and this actually functions correctly. And so it's reported that we've got an 80386 without FPU, and that's true. CPU instruction set 386. It's at 16 megahertz. I looked down to see the CPU version from BIOS, the 2308 hex, meaning again of that is a 386 SX, okay, and it is the C step effectively, and it's even labeled on the CPU. I've looked inside this before, and that's pretty common for by the time that the 25SX came out, that they were putting in the C-step CPUs. And so I know that it's gained, CPU version from BIOS. And so getting to just do escape to get back out to the command line, and we are going to go through and we don't even have to get out to the root directory. We can just, DOS is in our path. We can do the debug, and I'm going to go through and do the same dump of just to learn the EBDA, that extended BIOS data area, the segment for that, because even there's not an official location. It was up to the implementation on each computer. Now there is typically the standardized address that we saw with the 55SX, that 9CF0 is commonly the EBDA segment address. Not always. So we're going to do the length of just 16 bytes again. And we get to see pretty much the same thing as far as serial ports and parallel ports for the basics on the planar that IBM did. And then we see that same extended BIOS data area segment of 9FC0. So we're going to do a dump 9FC0 :0. We're going to do the length again of 160 in hexadecimal, and we get looking at the center of the screen here for the B6 hex and B7 hex locations, those offset locations. We just see zeros. And I did dig around and look in the UNPC book a little bit more. I thought, well, it's got an area that goes over the extended BIOS data area of the layout of that, and I didn't find anything. And thankfully Tom had given me the right locations for the 55SX, because in the UNPC book they do identify, hey, there is cases for the extended BIOS data area to have that CPU family and stepping values that are stored within it. And it actually told me that there's the offset is EF and F, EF and E, and it's giving me EE hex and EF hex is the offset for that. So if we actually look over in the two columns for that at the, going down some lines until we get to that, to the row. And I wish I still had a mouse pointer that I could do on the screen just to kind of show the area I'm looking at. Well, we're looking at the line of 9F C0:00E0 going across that table of information, and there indeed is that 2308. Now here, and Frank Van Gilwe goes over and explains that what's in the offset EE hex, that 23 value, that is the CPU family. So it's a little bit different. It's not big Indian in this case. And then the 08 is the stepping value. And that's showing the same thing that the UNPC program just showed us a moment ago of 2308 hex. So it's in a different location on the 25SX, but it's still in that extended BIOS data area. And I'm still grateful, to Major Tom for figuring out where it was with the 55SX. And now I know some of the areas to look for in these models that don't have the extended CMOS when I go through to revise this page that I have up, and going through, and I can identify down here that talking about where that's retrieved, those values are retrieved from extended CMOS. Well, that's not the case, and I'll go through and fill out the models more appropriately of how they gain that information. So one of the other models that we do have identified that supports this is the L40SX. And I wasn't showing earlier, in Debug, normally when you want to quit it, it's just a Q command. So you already have the tools. This would be something you could look up if you had some of these models that support the that CPU reset signature without having extended CMOS. So we're going to do Q for quit. Enter. Gets us back to the DOS prompt. I'm going to go through and pull the 25SX off the bench, and we're going to put up an L40SX. Okay, and I can show a little bit of the L40SX. I mean, it's booted up. It doesn't have, and I'm running that external display, so we don't have anything on the built-in display. We've got that using that VGA connection on back, and I don't have L40SX doesn't have any provision for the external keyboard either. So I'm going to have to, turn away from the computer in this case, and I'll probably move the webcam out of position and then get it back in position later on. But we're going to do the same thing. We're going to go through and get into the UNPC program and run it. Okay, to get to the system information and then that CPU information. Okay. And the showing, and the interesting thing is, and we can probably, in fact, let me go through. I'm going to briefly turn on the webcam again. going to kind of look down, and I'll have to look to see where I'm at. I don't have that really showing on my screen. But, you know, here is the 386SX CPU. And then I actually have a 387SL math coprocessor in there. And that has a later core that Intel did for the 387 math coprocessors. Even the 287XL has that same core in there as well. So the only reason I'm showing that on video is that the UMPC program could have probably identified that a little bit better. And I thought they could have gone through and identified it's a 386SX. I mean, they're identifying the CPU class all right, but they're identifying that math coprocessor, the 80287, that's incorrect. It's got a 386 or 387 math coprocessor. But we're seeing that same CPU version from BIOS, being that 2308 hex, meaning ultimately a C class. I mean, I could have shown that CPU on the inside the L40SX real easy, that it's marked as C step on the actual CPU, showing that. So we're going to go through, we'll escape, and this is the regular BIOS data area that I was talking about. And as I say, sometimes it takes a little bit of time. And so there, the layout is, you know, showing that serial port address, IO address, port 1, showing if there's a value in there or not. On the L40SX, I actually have a second COM port in the internal mode that's in there. So it's showing those COM1 and COM2, and then the first parallel port of that 03BC hex again as the IO address. And then, you know, looking down there, we see it laid out, the extended BIOS data area segment. And I mean, I can pull that up. We're going to pull up Debug in a moment anyway. But I want you to notice, before on the 55SX and on the 25SX, that was showing as 9F-C0. Here it is 9F-40 hex. So you want to you understand where you're wanting to look for data from, because if you look in the wrong place, if we made the assumption, oh, we just go to that the 9F-C0 hex is the extended BIOS data area segment, we're looking in the wrong place in memory. So you want to go through and verify some things, you know, when you're looking for them too. Okay, so we're going to go through the same way. We've got DOS in our path statement, so I can go through and get into debug. We're going to dump, and we're going to go through and look under debug, that same information, length of 16 bytes. And again, you know, showing that 9F-40 for the extended BIOS data area of the, you know, the segment for that. So we're going to go through and do I'm going to move the webcam out a little bit of the way. I'm going to do a dump 9F-40 and then a colon 0 length 160 in hex. Okay, and you know, sure enough, just like the 25SX, there is get to looking at the right, yeah, okay. So for the B6 and B7 hex address that we would have, like on the 55SX, those bytes are zeroed out again. But the same location, the same offset within that extended BIOS data area, is visible there. That 2308, once again, that value there, looking at the, all the way to the line of the 9F40:00E0, that line going over to the EE and EF hex offset location to see that 2308. So that's where the L40SX saves it. So, with the idea of the extended BIOS data area, that segment can be different. We've learned to locate it in the instances on machines that, they're not microchannel. They don't have the extended BIOS data area, even if they are microchannel, like the 55SX. Now, I do want to get back to a little bit to the 55SX. I did show the planers on that video. There's a Type 1 planer, and in fact, I still have them around. I guess I just shuffled them off to the side. I should have prepped a little bit more of the videos. I showed those on the webcam before, but there is the Type 1, and as we discussed, the Dallas module, that DS1287 for the real-time clock and the regular CMOS is here. And there's not any spot for that extended CMOS RAM, that module, that DS1220 module that provides that 2 KB of extended CMOS. Now on the Type 2, and we'll shuffle through. I have all my Type 1s on top. Okay, let's get to a Type 2. Okay, there's our Type 2. I don't know if that's very visible the same way, but that's where it goes through. And the Dallas module, the DS1287 module, is put in, parallel to the BIOS chips, and then it has that empty socket for the DS1220 non-volatile RAM module that can be put in here, and that's put in the instance of the making this into that model 55LS, that land station model. Where you go through and it's got different BIOS, and it's got that module in place, and then you have even the different riser. Gives it a different planar ID. And Major Tom studied things, and he says, the 55LS, you have that module in place, that DS1220 module with the 2 KB. So you're putting on extended CMOS on the planer. He says, you know what? The BIOS for that 55LS, it's using that extended CMOS RAM for storing the value of that CPU reset signature in the expected location and everything else, working like I had on that page. So it's very much like IBM came out with the Type 1 planer. Didn't have the space for extended CMOS. They were fine with that. And then it seems like they figured out that they were going to need extended CMOS, or they'd like to put it in the design. And so they came out with that PS2 model 55LS. And that being the land station model, it was normally designed not to have a local hard drive in it, and it actually booted from the network, what's called Ripple over the network. But they took a lot of the BIOS functionality that other microchannel models had, and using that extended CMOS area, and they incorporated that back into, in other words, made the 55LS finally behave like the other PS2s with that extended CMOS. So when the extended CMOS is there, it's used for that CPU reset signature. When it's not, it falls back to an area of the extended BIOS data area in memory, and every time the system boots, it's going through and plugging that value in. And I'm sure when it's an extended CMOS, when the system powers on, even though that's a non-volatile storage location, it's refreshing that information for if there was a CPU that was changed during the time that the machine was powered off or something like that, maybe. So that's just an overview of the convoluted things of, what I was looking at and kind of started to realize with that lack of the extended CMOS, started looking around of where the value of the CPU reset signature was held. And Major Tom was a major help in this instance in finding that information. And we've hit on some other areas of the installing the BIOS. It's been probably an interesting journey for him in looking at some of the stuff, and he's able, with his analysis that he's done on system BIOSes before, he recognized some of the things, but he's found code in there that is that gives a little bit better indication on how those systems were designed, and even for him to develop some theories and give a little bit more insight to the BIOS of those machines, and how IBM appeared to want a unified BIOS originally. The MAL, for the MAL 50, the MAL 60, all those machines that had 286 or 386SX CPUs on them, for the BIOS to be all relatively the same, and then differing from that model later on, and going through and how they came up with some of the differences. And so it gave, it's starting to provide those insight for other study areas as well. But that is the CPU reset signature in brief again, as well as showing the page that I had before of those covered models and the supported models that I listed there. And I'll have to go through and check on some of these models that I have, the 35SX, 40SX, to see how they store that away. Some of the laptops, we have the MAL L51S, or excuse me, the N51SX, and IBM uses the letters L in like the L40SX. That means laptop is the meaning of the L. The N for that MAL N51SX, and they have the N51SLC as well. That is a notebook computer, and it's over the Model 50, over 50 for the indication that it's considered a microchannel system. The way the system operates internally is a microchannel mechanism. So it'll be interesting to see the number of, how it holds the CPU reset signature on those models, whether it has extended CMOS. I'll get through and looking at those models in due time. The MAL 53 SLC2, that'll come out later on. That's based on that reply planar, and then IBM also having basing the MAL 55 LS486 on that same planar, and that's when they put in that Dallas, the DS1387 chip that has also that 2 KB of the extended CMOS built into that chip. The same one module instead of the DS1287 and DS1220 modules that had those areas separate. The DS1387 combines both areas. So I'll go through and I'll revise the this chart, and show how the mols go through and store that CPU reset signatures, and say, it's determined that they all do it differently. Sometimes they have different areas within that extended BIOS data area, or different segments for that extended BIOS data area as well. So I'll put that in table form, line up all that data so it can be a reference. If you've enjoyed this very unusual content, once again, click on that like button, show your appreciation. By all means, if you think any of this portion of confusing, I didn't explain it correctly or anything like that, leave a comment, and I will address that comment. I'd love to see comments from subscribers, and I want to grow my subscriber base. So if you are not subscribed to the channel, please subscribe. But this is IBM Museum. That's all I have for now. Thank you.